Hi, I am Arunabha and this is my project on molecular dynamics. So this was one of my projects for ME 69700 computational fracture mechanics. So the title of my project was Diffusion Modeling in Sintering of a Nickel Alloy Using Molecular Dynamics. So molecular dynamics is actually the study of the behavior of atoms and molecules inside a particular material or substance. It's generally governed by the Newton's equations or laws of motion, and using molecular dynamics, specifically like the embedded atom method, we can simulate the movement of atoms or molecules inside the substance. I'm going to go through the objectives of my project. I'm going to give a brief overview of molecular dynamics, the simulation of diffusion phenomena, the sintering phenomena actually, and in the sintering the diffusion phenomena explained by molecular dynamics, and then the results, and I'll provide some conclusions. So molecular dynamics is actually a computer simulation method used to study the behavior of atoms and molecules in a system where there are a large number of particles interacting among themselves. It actually solves equations based on Newton's laws of motion, and we need to find out some forces or potential energies that we can find through usually the Lennard-Jones potential. There are also other potentials, but this is the most significant one here, and this is the expression for the Lennard-Jones potential here. Like this, R stands for the radius, this is for the strain, sigma is for the stress, and Vij, this is the potential actually. So for molecular dynamics, actually this is an open source software like LAMMPS. This is like the LAMMPS code, this is the input script. We need to provide an input file for the simulation along with the LAMMPS system file, and we get the output desired results. So this was like we need to first define the geometry of the material, the dimension, the boundary, the units, the atomic style, the neighbor. So this was like the temperature, this was the variable here. So these are the syntax LAMMPS generally uses, and this is where we give the EAM file. We need to have an EAM file along with the input script for this particular simulation to work. So this is the dump file. The dump file will be generated after the simulation is over along with the log file. So this was the result that I had got after the simulation was over. I could view this in VMD, the Visual Molecular Dynamics. That's a software for visualizing the results generated by molecular dynamics technique. So as we can see that these are the two particles. This was a two particle simulation, and in these two particles we can see there is a necking region which holds these two particles here, and as the simulation proceeds, when this to separate, this necking region tends to increase along this longitudinal axis. This was like the simulation, the necking region actually increases. So this was just an elementary presentation of how LAMMPS can be used to utilize the molecular dynamics technique to simulate the behavior of atoms or molecules inside a particular material. Here is the nickel alloy. So some conclusions, as I can say that it was found that during the diffusion of atoms, the necking region between the two particles gradually increased in width, and the Lennard-Jones potential, as I described earlier, the relation that's very important in determining the potential energies. Also, input parameters are very important to provide for getting the desired results. We can get results like the final temperature values, the activation energies, the deformation, the stress, the strain values. Also, tensile tests can be performed using molecular dynamics to characterize mechanical properties of a product, like a manufactured product. Thank you.